All right, in this lesson, we are going to look at the remainder and factor theorems and also some really helpful applications of synthetic division. And so first of all, the remainder theorem says that for some polynomial p of x, the remainder of the quotient p of x divided by x minus r is equal to p of r. Okay, and so we're just going to show that that is true with this example. And so here we're given a polynomial p of x equals negative 3x squared plus 5x plus 4, and we are going to divide it by x minus 3. Okay, and so dividing that polynomial by x minus 3 using synthetic division, we would put the root of the divisor, and so the root of x minus 3 would be x equals 3. And then the coefficients of the polynomial we're dividing will go at the top. And so negative 3, 5, and 4, and we're not missing any terms. We have our x squared, our x, and then our constant. Okay, so bring down the negative 3, we get negative 3. Negative 3 times 3 is negative 9. Add, we get negative 4. Negative 4 times 3 is negative 12. Add, and we get negative 8. And that negative 8 is our remainder. And so p of x divided by x minus 3 would be the polynomial negative 3x minus 4 plus the remainder over the divisor. Okay, and so just keep in mind that this number here is the remainder. Okay, and so now when I evaluate p of 3 according to the remainder theorem, p of x divided by x minus 3 should equal, the remainder of that should equal whatever p of 3 is. So p of 3 just means we are replacing the x in p of x with the 3. And so notice we have x in two places. And so if I replace that x with a 3 and then evaluate, we would do negative 3 squared first and get 9. 5 times 3 is 15. Negative 3 times 9 is negative 27. And then negative 27 plus 15 plus 4 gives me negative 12 plus 4, which is, in fact, negative 8. Okay, and so p of x divided by x minus 3 is equal to, or the remainder of that is equal to what p of 3 was. Okay, and so using this idea, we can do something called synthetic substitution, and it's a method where we use synthetic division to find the value of a function. It's helpful when trying to evaluate this function. Sometimes these numbers can get very large depending on your degree. Okay, and so for example, this isn't too bad, but you can see how it could escalate very quickly. If I'm trying to find p of 4, I can use synthetic substitution rather than, usually we would have to replace all the x's. I'm just writing it down to show you what we're doing instead to replace this. We would replace all the x's in that original polynomial with 4 to figure out what p of 4 is. So we would have to figure out 4 to the 4th power times 3 and compute all this mentally, whereas if we use synthetic substitution, the numbers typically stay much smaller. Okay, and so using synthetic substitution, we put the root of the divisor, which is here, because our divisor would be x minus 4, the root would be 4. So whatever number you see in the parentheses actually just goes into the synthetic substitution. And to do synthetic substitution, we write the coefficients. And notice we're missing our x squared term, and so we're going to have a 0 as a placeholder. And so 3, negative 2, 0, negative 10, 2. That placeholder is so important. If you don't have it, you're going to be able to do all of this and not even know you're doing anything wrong. Okay, and so bring down the 3. 3 times 4 is 12. Add, we get 10. 10 times 4 is 40. Add, we get 40. 40 times 4 is 160. Add, we get 150. 150 times 4 is 600. Add, we get 602. Okay, and so P of 4 is equal to 602. And we can even verify that in a calculator. And so if I were to plug in 4 into that function, I would have to use my parentheses and just type all this in. Minus 2 times 4 to the third minus 10 times 4 plus 2. Okay, and so we do get 602. Okay, and so in this next one, you can see how this is going to save us a lot of time. Put the -2 here, and then we have 4 need 0 as a placeholder because we're missing our x to the 4th term, and we're also missing our x term. So we're going to have 4, 0, 2, 2, 0, 1. We need both of those placeholders. Okay, bring down the 4. 4 times -2 is -8. Add, we get -8. -8 times 2 is +16. Add, we get 18. 18 times -2 is -36. Add, we get -34. -34 times -2 is 68. Add, 68 times -2 is -136. Add, this was a -1. Add, and we get -137. Okay, and then if we check this in a calculator, we're plugging in the -2, so 4 times -2 raised to the 5th plus 2 times -2 cubed plus 2 times -2 squared minus 1, -137. Okay, and so Q of -2 is 137. Okay, so that's just a cool application of synthetic division, very helpful if you don't have a calculator. And so in this next example, it says use synthetic division to evaluate P of x divided by x plus 3. And so using synthetic division, 2, -3, -17, 30 would be the coefficients. We have our x cubed, x squared, x, and 30. And then the root of the divisor is -3. Okay, remember the root of the divisor goes there. Bring down the 2. 2 times -3 is -6. Add, we get -9. Multiply, we get 27. Add, we get 10. Multiply, we get -30. Add, we get 0. Okay, and so we've talked about this a little bit, but when we get 0 as a remainder, that means x plus 3 is a factor of P of x. So if we were to factor P of x, this degree 3 polynomial, we would get x plus 3 as one of the factors. Okay, and so since the remainder is 0, then P of -3 would equal 0. This means x plus 3 is a factor, and that x equals -3 is a root or a 0 of the original polynomial. So if it's a root of this factor, and this is a factor of the polynomial, that means it's a factor of the original, it's a root of the original polynomial. So the factor theorem says any binomial x minus r is the factor of a polynomial if P of x equals 0 or P of r equals 0. When you plug this in, you get 0. And so we've been using the factor theorem to find all the factors, and so we're just going to do some more examples of that. And so determine whether x minus 2 is a factor, and if so, find the remaining factor. So we're looking for a remainder of 0. Okay, and so using synthetic division, writing down the coefficients of the polynomial, x cubed minus 7x squared plus 4x plus 12. And then the root of the divisor is 2. So bring down the 1, multiply, we get 2, add, we get negative 5, multiply, we get negative 10, add, we get negative 6, multiply, we get negative 12, and then add, we get 0. So yes, x minus 2 is a factor. And so now to find the remaining factors, remember you drop your degree by 1. So the polynomial I'm left as the quotient is x squared minus 5x minus 6. That's a quadratic we can factor. We just need two numbers that multiply to negative 6 and add to negative 5. That would be negative 6 and positive 1. And so my factors are x minus 6 and x plus 1. So my remaining factors after the x minus 2 are x minus 6 and x plus 1. Okay, so those are the three factors that multiply to give us this degree 3 polynomial. Okay, on this next one, it says, show that x plus 4 and x plus 3 are factors. Okay, so we're going to use our synthetic division, and we're actually going to stack it. So we're looking for remainders of 0. And they're saying show us, so we're going to show them that the remainder is 0. So my coefficients are 1, 9, 23, 3, negative 36. We're not missing any factors. We're not missing any terms. And then let's start with the x plus 4. So negative 4 would be his root. Bring down the 1. 1 times negative 4 is negative 4. Add, we get 5. Multiply, negative 20. Add, we get 3. Multiply, we get negative 12. Add, we get negative 9. Multiply, we get 36. And then 0. So therefore, these three dots means therefore. X plus 4 is a factor because the remainder is 0. Okay, and so now we can just show that x plus 3 is a factor of this quotient. Okay, so the negative 3 would go here. Bring down your 1. 1 times negative 3 is negative 3. Add, we get 2. 2 times negative 3 is negative 6. Add, we get negative 3. Negative 3 times negative 3 is positive 9. Add, we get 0. And so therefore, x plus 3 is a factor because remainder is 0. And so our quotient, we have to drop our degree by 2 because we just factored out 2 linears. So now from degree 4, we're at degree 2. And so this is x squared plus 2x minus 3. Two numbers that multiply to negative 3 but add to 2 are negative 1. No. Yes, negative 1 and positive 3. And so x minus 1 and x plus 3. And so the remaining factors are x minus 1 and x plus 3. So these are the 1, 2, 3, 4 factors that make up this degree 4 polynomial. Here we had 3 factors that made up this degree 3 polynomial.